Hi, welcome back to our third video of Unit 9B, Day 1. We're looking at tangents. We discussed that a tangent is a line or part of a line, a segment, that intersects a circle in exactly one point. That point is called my point of tangency. It is always perpendicular to a radius. So we can decide if we have a tangent segment by trying to apply the converse of the Pythagorean theorem. If a squared plus b squared does equal c squared, then we do have a right triangle. If it does not, if they're not equal, then no, we don't. So this is not a secant segment here. Okay? And then we can also, if we know we have a tangent, we can use Pythagorean theorem to find missing pieces. Remember one quick note, remember if your number is showing that it's just part of that segment, you have to add another radius to it to find that whole length there. Okay? The second thing we discussed is two segments from the same exterior point are tangent to a circle, then they are congruent. So these two segments are going to be congruent to each other because they're tangent at T and R, and they intersect at this common outside point, S. And the last thing we discussed was if we have a polygon circumscribed about a circle, every single side is going to have a point of tangency on the circle. And then because of that, we are always going to have two sides that come together, two tangent segments that meet at an external segment, so I know these two pieces will be equal. Okay? Let's look at some mixed practice problems and see what we can learn. The first one says, is segment KL tangent to circle JK, circle J? Okay, so let's see. What I want to do is I want to say, okay, if KL is tangent, then I want to know, is there a right angle right there at L? Okay, so that means this segment here is going to be my hypotenuse, if it is. Okay, remember that's this whole length here. Okay, that whole length is not just 9, that whole length is 9 plus the radius, which we can see here, is 8. So this whole length here is really 17. So that's going to go in for my C when I do my A squared plus B squared. Does that equal C squared? So I'm going to have 8 and 15. Does that equal 17 squared? Okay, so let me get my calculator. 8 squared is 64. 15 squared is 15 times 15, 225. And if I add these two together, I get 289. So now let's see what the square of 17 is. So 17 squared, or 17 times 17, is also 289. So they are equal, which means yes, KL, segment KL is tangent to circle J. Okay, let's look at the second problem. Find X given that JK is tangent to circle H. So this time they've told me I am tangent, so I really do already know this is 90 degrees. And I'm trying to find this whole length here. Okay, so I can use my Pythagorean theorem. I can do it either with the shortcut way, or I can do it the regular way. If I'm doing it the shortcut way that I taught you earlier this year, my hypotenuse is the side, I'm trying to find that whole length of the whole hypotenuse, right? So that means if I'm trying to find a hypotenuse, it's going to be the square root of, I'm going to add the two together. Hypotenuse means add. If I'm looking for a leg, I'll subtract. I have 20 squared, and I have 15 squared. I usually put the bigger number in first. So that's going to be the square root of 20 squared is 20 times 20, which is 400. 15 squared is 15 times 15, which is 225. So when I add those two together, I get X equals the square root of 625. Okay? And then what I need to do, if I have it like this in my phone, I can just turn my phone sideways and look for notice I have a couple of them that look like squares. I want to use the one that has the 2 on it because I'm square rooting, right? Later we're going to talk about cube rooting. I'm going to use the one with the 3. But when we square root, we use the one with the 2. And I can see the square root of 625 is just 25. So X equals 25 units. we go. All right, let's look at the next one. Find x and the perimeter of the circumscribed triangle below. So if I want to find x, x is that whole side, okay? I know that if it's circumscribed, that these are tangent, so tangent, tangent. So I've got my little piece here. These two are the same. Tangent, tangent, external point, so these two are the same, 13 and 13. Tangent, tangent, external point, so these two are the same, 17 and 17. So this length right here for x is 13 plus 10, which is 23 units. Then the perimeter is going to be this 13 plus 17, which is 30. This 10 plus 17, which is 27. And this side here that we said was 23. So I just need to add those numbers together. So when I add them together, it's going to be 30 plus 27 plus 23, and I get a perimeter of 80 units. Okay? All right, let's look at the next one. QR is tangent to circle P, find X. So again, they told me I am tangent, it is tangent, so that means I do have a right angle, which means I can use Pythagorean theorem. I'm looking for this whole hypotenuse, so since I'm looking for a hypotenuse, again in my square root, I'm going to add. Remember, if I'm looking for a leg, if I was trying to find the radius of that circle, or if I was trying to find the length of this piece, this tangent segment, then I would be subtracting in here because I'd be looking for a leg. All right, so if I'm looking for my hypotenuse, I take my 24 and my 17. I usually put the bigger one in first, squared and squared. So x equals the square root of 24 squared, 576. 17 squared, 289. And when I add those together, x equals the square root of 865. Oops, did something wrong there on my calculator. Sorry, 576 plus 289 is 865. I'm going to turn my phone sideways so I can square root, and I get a decimal. That's okay. X equals 29 point. Now, if we're going to round to 3 places, because that's how we've always been rounding this year, I look at 3 places, 410, and then I look after the 0 and say, do I need to round up? Yes, I do. So I'm going to round that up to 411. Okay, 411. And I have units. Okay, let's look at the next one. The next one, find x and the perimeter of the circumscribed triangle below. So, oh, this is the same problem as this one. We've already done this one. I already know that x is 23 units, p is 80 units. Somehow this problem got in our notes twice. Same problem there. Okay? All right, let's look at the next one. Find x in the perimeter below. So this one's a little bit better because it's a new problem. All right, so doing this one, I know if this is 2, this is 2. If this is 6, this is 6. If this is 4, this is 4. So x is 10. Okay, and then here, 6 and 2, this side is 8. 2 and 4, this side is 6. So my perimeter is going to be 8 plus 6 plus 10, which is 24 units. All right, we just have a couple of examples left. We'll do those in the last video. again, looking at tangent segments to a circle. We'll do those last 5 problems in the next video. Thank you so much for watching. Come on back for the last examples.